Hello again. We're going to finish up our lesson on finding the sum of a geometric series. We're going to do a little trickier problem, and we're going to do one with some sigma notation in it as well. So we're going to look at, again, we need this formula. If I want the sum of n many terms of a geometric series, this is the formula. And the problems we did before, we had to look at our series and try and figure out what our r was, but we knew our first term and we knew how many terms we wanted. We ended on this question right here, which is a little bit trickier, because the things that I know, looking at this, I can see that my first term is 2. Also, I need to make sure, is this geometric? So if I think about this, 6 divided by 2 is 3. And if I did 18 divided by 6, again, I get 3. And if I do 54 divided by 18, I get 3. And I can see just even from looking at it, in this case, this was one of those ones I could probably eyeball and say, oh, I'm just multiplying by 3 every time. So I know that my r is 3. All right. But the problem is, find the sum. I need to know which term is this. This is my a sub n, but what's the n? So I have to figure that out. There is a really cool algebraic way, and I'm going to make a separate video for that. But since we are distance learning, we are going to try to do the down and dirty. We're trying to make this as simple as possible. So in either case, the thing I need to think about is I need the formula to get these numbers. So not the series, but the sequence formula. And for geometric, remember our sequence formula is the nth term is our first term times our common ratio to the n minus 1 power. So what I know is my first term is 2, times my ratio is 3 to the n minus 1. And that's my an. In other words, I can put this, so we're going to use our graphing calculator. I haven't figured out how to do this in Desmos very well, but if you have the graphing calculator, and I come up here and I go to my y equals, I can type in 2 times 3 to the n minus 1 or x minus 1 power. And then I can look at my table and try and figure out where I hit that number of 118. It was pretty big, and I keep going. Oh, there it is, right there. 118098. Was that the number I was looking for? Let me see. 118098. Okay, so what that tells me is that n in this case would be 11. Okay, so now I have my last piece that I need to do my formula, because basically I was solving this. I was looking for this in my y. I wanted to know what n made this happen. So that's what we just did. So now I know n is 11. Now I can go back to my sum formula. So that was using my sequence formula for geometric. Now I can go back to my sum formula and say, I know that this is adding up 11 numbers. And so I take my first term times 1 minus my ratio to the 11th all over 1 minus my ratio. You should try and stop the video, see if you can figure that one out. And hopefully you got this answer. Or hopefully I'm right. If I'm not right, you should send me an email and say, but this is what I got for the sum of all these numbers in this list. Okay. And if you want to see how to do this algebraically, I'm going to put a video about that up because it's kind of cool. So the last one we're going to have is what happens if they haven't given us the list, but they give us this thing in sigma notation. How do I do that? So once again, hopefully you can see from looking at this that this is geometric, right? Because we have some ratio and we have it to a power. Oops, that's not very good. But if you're not sure, one thing you can always do is sort of come up with the first few terms and see what we're getting. So I start with I is 1. So when I is 1, this is -2, and I do 1 minus 4 to the -3. So that means to the -3 power. 1 minus 4 is -3, which is, and again, parentheses would be big. So I'm raising negative 2 to the third power, which is 8, but the negative exponent is this, and since it's an odd power, I'm going to have an odd raise, a negative number raised to an odd power will give me an odd answer. When I is 2, we're going to have our negative 2, and this would be to the 2 minus 4, so now we're to the negative 2 power. So again, I raise negative 2, I square it, I get 4, but the negative exponent is 1/4. When I is 3, so again, I'm trying to figure out what my common ratio is because I need that for my formula. So when I is 3, I'm going to do negative 2 to the 3 minus 4. That's just to the negative 1 power. And again, this is going to be a minus because I'm raising it to an odd power. And hopefully you can see that the common ratio here, pause, take a minute, can you find it? Hopefully you came up with negative 1/2. I think this gives me everything I need to know to figure out the sum. So I want my sum, right? Because this keeps going. We're adding up more numbers. How many terms? So the things I need to know, how many terms? That's usually right here, especially as long as I'm starting at 1. I'm going to do I is 1, I is 2, I is 3, I is 4, etc. That means I'm going to eventually have 15 numbers to add up. And my geometric sum formula says you take your first term, which I found right here, negative 1/8, 1 minus my common ratio, again, parentheses are going to be super big in your calculating, to the nth power. We had 15 terms we wanted to add up, and I'm going to divide by 1 minus parentheses, again, parentheses, negative 1/2. So the bottom is really 1 plus 1/2, or 3/2. Again, pause the video, see if you can get the correct calculation. You're back. I don't know about you, but when I did it, I got negative 0.08, and then a bunch of 3s in a row, and some more stuff, but we'll round if we're going to the nearest thousandth. So it's approximately negative 0.083. So hopefully now you have enough to do your work. Oh, I guess I didn't know I had one more problem. Maybe we'll save that for one more video.